Okay, so again, everybody. So my name is Yoni Engel. I'm the VP of Business Development for AlmaScience. So thank you for being here, and thank you, Diogo, for an interesting presentation. In my presentation, I'm going to recap on some of the things that we've already heard before in the previous presentations. Just giving kind of the status of how we see connected packaging today. But following that, I'm going to introduce you with some technologies and projects that we are working on at AlmaScience, and that we hope can build another layer of innovation into these applications. Before going into the technology part, I'll just say again a few words about AlmaScience for those of you who don't know us, and maybe for those of you who know us and don't know everything we do. So AlmaScience is a sustainable tech applied research organization and is a part of the Portuguese Strategic Innovation Program. We are supported by the National Innovation Authority, ANI. We have a team of about, a multidisciplinary team of about 25 PhDs and researchers that are expert in areas such as material science, paper technology, electronics, printing technology, chemistry, and biology. And as Carlo mentioned earlier in the opening talk, alongside these very impressive technology competencies, we are very business and commercial oriented. So we work with industrial partners in order to commercialize IP and to create disruptive technology that creates high economic impact, but low impact on the environment. We focus our innovation on areas such as paper electronics and the use of engineered biocellulose and cork-based materials. We do that specifically for these materials because they are readily available, inexpensive, safe, sustainable, and already have a very large production and recycling capacity in place in the industry. So it is our belief and our associates' belief that by using such materials, we can enter an era of sustainable technology, achieving progress while respecting the environment. More specifically about the 4 areas that we work in, or the projects that we're involved in right now. The first is using, as I mentioned, biocellulose materials for life science and for material science applications. The second is large area paper-based electronics for smart home and smart surfaces. And the 2 other that are more focused on what we're talking about here today are focused on connected security and connected product monitoring throughout the supply chain. We are not alone in this journey. We are part of an ecosystem, or what we call the smart paper ecosystem, which is composed of academic partners, leading academic partners here in Portugal, research institutes, and industrial partners that help us to translate advanced technology from academia to commercial applications. Following that brief introduction, let's go back to connected packaging. So it was said here in many words, but in fact, what we get when we create the experience of connected packaging, we bring the product to life. Instead of just a simple label that we have on the product, okay, you can change it. The product is ready and it's going outside. You create a digital dimension or a digital twin of the product that can be modified according to the need. And you can share all sorts of information with consumers or with other stakeholders in the supply chain. So how can we do that today? Today we have all sorts of methods. Most of them were mentioned: QR codes, NFC, RFID. You can scan the product optically. You can tap on it with your phone. You can read it with an RFID reader, and you can get the information. You can, of course, have a Digimark embedded in the product. And that's you've heard about all of what that product can do before. And that mainly serves to create, besides benefits in operational, I'm moving beyond the operational part of the benefits of tagging the product or serializing the packaging. I'm looking at everything that happens once the product leaves the factory. It's a mainly brand and consumer direct or I guess unmediated connection. But what don't we get from that solutions that we have today? So when we talk about solutions like the product digital passport, we can know when the product was produced, how it was produced, all sorts of information that the producer wants to share with the consumers. But first of all, we don't know if the information is real, because information carriers can be tampered with, can be replaced. You can print a QR code and link it with whatever website you want. And if you don't scan that QR code with a secure application or with an application of the brand, then, and you just scan it with your regular QR reader, it can basically direct you to a website that looks exactly like the website of the producer, and you'll never know that. On the other hand, the other option is to install specific applications. Like Gunnar mentioned, something that would require, in some locations, installing 50 different applications. So maybe, starting to become a little bit cumbersome for applying that. The second thing is that we don't have real-time condition monitoring. This concept was already introduced by Diogo, but we do want to know what is the condition of the product at every step of the way, whether it's minced meat or other products. We don't want it to happen discreetly at stations, but we want the product to always be communicating about its condition in the supply chain. And the last thing is that, or the two last things is that, first of all, it requires a line of sight mostly, besides RFID application. So you need to actually scan the product. You need to have visual access to the product. If it's a box that contains secondary packaging or packaging inside, a box that contains 100 products inside, you can't scan one by one. You can rely on aggregation. So you can scan the container and receive aggregated information on what's inside. But if anybody tampered with this box in meanwhile, then maybe the information that you're getting is not really reflecting what's inside. So overall, we still have a way to go in the value that we can generate to the supply chain itself. So challenges. Security. We want to get real elevated security for products. And I chose the strawberry on purpose because maybe you would say, okay, who cares about security when you talk about strawberry? But the challenge is to make these solutions available even for applications or for products that may not be premium products or super expensive products. Like if we're looking at the holy grail of applying these solutions. And also if you're giving your kid a strawberry that has pesticides inside, maybe that's important to you like a passport is for border control. So security, we want to know that the information that we're reading from the product is real. We want to know the condition of the product at every step of the way. We want that to be connected. So we want that always to be talking to the supply chain in a seamless and connected way. And we want to do that, and Gunnar mentioned that, we want to do that in a way that doesn't affect the recyclability of the package. So we don't want to throw a lot of electronics on that package that make it irrecyclable in the paper recycling stream, for example, or in the plastic recycling stream that it's applied on. So the first thing that I'm going to address is connected security. We addressed that in the framework of our technology division Sphinx idea. And the first, I'm going to introduce you with two concepts or two projects that we're working on. The first one is RFID Plus, which is the first physically encrypted RFID tag, as far as we know. And that is something that we obviously want to extend our collaboration with the INCM. So feel free to talk to me about that later. So normally when we work with a regular RFID, we send some inquiry using the RFID reader, send an RFID signal, and then we get an answer. The answer is a coded information that can either be the information that we're reading or can have a unique product identifier that sends you to a website. That is not secure information. People can produce RFIDs that generate fake information, can tamper with existing RFIDs and change the information that they're responding to. And overall, it's not secure. What we are working on doing is adding another layer of RF question, which is, besides the information that you're giving me back, please authenticate and provide a unique authentication code. We're doing that by embedding physical materials into the RFID architecture which means that when we receive this secondary response, we're going to receive a unique, unequivocally authentic response that cannot be reproduced, because this is a very special material that is not available to anyone that could just replicate it. So that is the first project or the first concept that I want to introduce you with. The second one, I am introducing the concept again of two-factor authentication, but this is a pretty fluid kind of application field. There is many ways you could take this to. So here in this picture, we see a QR code or an information carrier. Of course, that could be a Digimark that's embedded in the package. The first thing you do is you scan the QR code. What you're getting is, you're getting an answer. Just a second, it jumped a little bit ahead. It says, instead, not only the information that you would get normally when you scan a QR code, but it basically tells you, you need to activate a pattern that's printed into the package, and you need to see the number 4 on the invisible screen that's embedded in that package, for example. You would do that and you would get a 4. Then you know that your package is really secure. Another way to do that, for example, like Diogo mentioned, is an NFC tag. So you would scan the NFC tag, get the information, but also power you would create the pattern. That pattern would trigger something that would create that number 4 in the display, given that you scan the NFC tag and power that display. So there's all sorts of ways to play with this architecture, or even to use it for other applications that are not mentioned here. So that was about security. Another project that we're involved in is about condition monitoring or connected condition monitoring. We're doing that in the framework of our activity, Smart Pack Technologies. The idea is, again, to make sure that the product is being monitored throughout the supply chain. So when we look at this fish, we would want to make sure that this fish is as fresh as promised at every step of the supply chain. For example, when it gets into the supermarket would want to know that the box that they're receiving then contains 50 packages of fish. All the fish in the box are at the freshness level that they paid for, and not at something at an inferior freshness level. Right now, you need to basically check one by one, or you need to do that visually, or you need to rely on some quality checks that are based on paper, for example. Embedding condition monitoring systems into the package that continuously monitor the quality of the fish throughout the supply chain would allow the supermarket to know if something happened along the way that affected the quality of the fish. Of course, we have applications that relate to smart pricing and food waste that follow that. So we are working on several aspects of embedding this technology. The first one is working on special paper that allows us to combine chemistry that is needed to monitor the condition of the product and electronics that are needed to communicate that to the outside world. All of that while considering that this type of paper needs to be in contact with food. So this is the first activity that we're working on. And of course, we're working on the chemistry and biology of sensing these changes and on the communication devices required to communicate that outside. Now, of course, all of these amazing features may create a huge disruption in the price of the package, because if you're building a Ferrari of electronics and chemistry on every product, you may make the price of that salmon considerably more expensive. So some of the concepts that we are working on in order to mediate the challenge of price is, the first one is working on printed chipless RFID tags. That means that we are working on printing RFID tags, taking the cost into the domain of printing QR codes. Now, that is not something that exists with us now, and we're not the only one in the world, of course, working on this technology. But we feel that our ecosystem puts us in a very good position to succeed in this task. So this is the first concept or the first approach to making the cost of these connected tags cheaper and affordable. The second approach that we are trying to apply is to remove the complexity from the package into stations along the supply chain. So maintaining on the product itself the most simple electronics and sensing elements, and removing the complexity into the stationary phases, like for example, the shelves in a pharmacy or the shelves in a supermarket. So in a use case like that, the consumer will not interact with the product with his phone, for example, but he may interact with the shelf that is going to relay the information that is coming from the product. So again, we're removing complexity from the product to the infrastructure. To summarize, when we're looking at the connected or the future supply chain, it's similar in a way to what we have today and to what we've seen before. But instead of having discrete scans along the way, we're having continuous monitoring of the product along the supply chain. We always know where the product is, that it is authentic, and what is the condition of the product. And we also can realize events that happen in real time if something bad happened to the product. Now, this is significant for many use cases, but e-commerce was mentioned here more than once. And I think that when we consider e-commerce, we can't rely on the end consumer verifying the product when it gets to the consumer, because that may be too late. And also that involves a lot of returns and a logistic burden that is now very difficult for companies to cope with. So it's kind of imperative to be aware of these supply chain deviations or infringements in a much earlier stage, where we could be alerted or indicated using physical sensors and data management systems that alert the brands or the shipping companies or the fulfillment companies of things that shouldn't be happening in the supply chain. We are getting the marketing and engagement that is already present today. We are getting an ever better supply chain visibility, increased brand protection, and also connected, condition monitoring in a continuous way, and circular economy data, because these connected packaging are going to basically keep their identity or their broadcast even when they go into the recycling stream. Just to leave you with a kind of a single use case of something like that, and maybe fresh vegetables that are in bulk is not the best example, but just as a concept, if we can know what is the actual freshness or what is the actual expiry date, like if Diogo had an example like that, we can use that, for example, for smart pricing. If you're making pasta tonight, maybe you don't care buying tomatoes that their expiry date is tonight, and you are willing to pay 50% for these tomatoes, and then you are saving money. The supermarket is making money on something that they would throw away tomorrow because the expiry date would expire. And not to mention that a lot of the times, not for bulk vegetables because we see that with our eyes, but for other packaged products, expiry dates are determined arbitrarily and not really based on the actual condition of the product. So overall, this could serve the consumer, the retailer, and also the environment, preventing food waste and resources being spent for products that are eventually being thrown away to the garbage. So I hope I introduced you to some interesting concepts today. And again, thank you for listening.
Okay, Yoni, thank you very much. So pass the word to the audience. Please, if you have any questions to put to Yoni, any comments.
Thank you for your presentation. When you refer to the labels about the freshness of the products, I think you need to do much more things. You need to know, you need to sense the methylene, because the state of a product depends on the methylene that and when they are going So this means that you have to have this type of sensor because it's important. Otherwise, you don't know if it is fresh or not fresh. And then you have to communicate. So do you believe, and then of course you have to communicate to the supplier that you have to change this product, or you have to move. Even if I have a tomato that is deteriorating, if it is in the middle of the others, it will deteriorate all of them. So you have also this type of selection. Did you make any type of calculations? What could be the saves on the supermarkets? Because this is, at the end of the day, is how much money you can make it.
Well, I guess that's without going into the technology too much, and completely right. In terms of food waste, I don't have the numbers in front of me, but the numbers for food waste are in billions of euros in damage every year from food waste. So having systems like this in place that can prevent even a part of that would make a significant difference in savings to different players, the retailers and other players in the supply chain. Again, not to mention the societal impact of preventing food waste. I hope that answered the question.
Any further question? Okay, if not, thank you, Yoni. I will just now close the session. So, and besides being also CTO of AlmaScience, I'm here today in my role of coordinator of the Materials Engineering College South Region from Ordem dos Engnheiros. And so my first word is for the team that have made possible today this event here at Ordem dos Engnheiros. And I would like to thank to Nidia and to Rita, especially because it was my interaction, but of course all the team that are also making the support here on the digital media that we have been using today. So thank you very much for your help. So I will not, of course, take much time just to wrap up here some of the ideas and the concepts. So we heard important concepts about how to improve the logistic chains, and to assure the safety and the authenticity of different products. We saw that this includes challenges with different solutions that could be implemented. We heard that one important point to consider is how to massify these technologies, because those are not available nowadays for all the products, as you may know. We know that when you go to a supermarket, many of these things do not exist nowadays. Not because the technology is not available, but because of the price at the end. So it's also a challenge to massify all this. And so it's not only important the technology that we use, but we also heard, and we clearly need to assume this, that we need to have a kind of cost-effective, but more than cost-effective, also a kind of function-effective selection when going for this technology. So we have different options to see which one fits the product. And this basically includes also what is nowadays known as eco-design. So eco-design is not only sustainability and recyclability, also to design a product that fits the needs, and that then, of course, then also considers then all the aspects of sustainability. We also heard about the connection between the physical world and the digital world. It's indeed where the challenge is. People say that normally the challenge is in the interface, if everything is physical or if everything is digital. It's easy to make this type of products that communicate with two worlds. It's more challenging, of course. But linking to what I said before, it's also important to understand what information we need to collect, what information we need to transmit, and who will assess this information along the value chain. So maybe the consumer doesn't need to know all the information. Also, the retailer needs to assess information until a certain point. Maybe the producer wants to have information about the product since the farm to the fork. But then other issues also may appear, because if we create a smart packaging, a smart solutions that start to gather information, to get information along the value chain, and if this information could be accessible to someone else, or could be, let's say, some informatic piracy, so you can enter in this information. So you are collecting information that is sensible, and we have privacy problems that could also arise, because we hear some concepts knowing about, okay, this guy took the bottle to Brazil and then he drinks in Nicaragua, so it starts to become important challenges also that need to be addressed. So basically this fits in my first comment, that is, okay, function effective and cost effective solutions that fits the need for this product. And to finalize, just to say, of course, we understand this is a kind of multidisciplinary challenge where we could find topics like electronics, like computer science, because we talk about data science, we talk about ICT, and of course about materials that make all this possible, but other like environmental science as well. So it's really, and I saw this in the presentation of Guneri, it's like engineering creativity. That was the prize that you mentioned, that indeed is what we need. So it's the creativity from the engineers that are working and developing these technologies. So, and to finalize, this means that this makes sense to have these discussions, of course, in the House of Engineers in Portugal here. And so that was a pleasure to have you here today. And thank you very much for being present. And I wish you a good day and a nice week. Okay, thank you very much.
No. It runs through all the other offices. Yeah.
So we can back home, right?
Yeah.
A lot of money on business.
So basically, last